So in the Chapter 2 lecture, we're really going to be focusing on how we can both identify good research and how we can be good consumers of research. And we're also going to look at one of the reasons, or a couple of the reasons actually, of why we need to do this systematically. In other words, kind of how we're actually bad at determining what's going on in the world. We are naturally set up, and there's been an enormous amount of research that has shown this, to look for patterns in our environment, which is good. That means that that's a step towards empiricism. We're looking for patterns, we're looking for observations. The problem is that we're usually then interpreting those observations and coming to a conclusion very quickly based on our experience. And that experience may not generalize to the rest of the world. And you're going to hear the word generalize a lot in this class. Whenever we're doing research, we're focused inwardly at the methodology. Did the actual researchers conduct a good experiment? Did they provide potential confounds? Did they think about other explanations? Did they create a control group, which is one of the things we're going to discuss in this lecture, is the need of that control group. But also, once that's done, can it generalize to the rest of the world? In other words, the more specific it is, the less it generalizes. And we're going to see that there's kind of a seesaw. The more you can generalize, probably the less methodologically rigorous it is. And that's one of the reasons that we also see multiple experiments being done whenever we're looking at one particular phenomenon. So we're going to look at the sources of information and why research is best and how to find it. So what defines research, how to find it, and also how to interpret it. So the first thing I want to start with, and we'll probably end with this too, is this kind of chart. Think about things that you believe. In other words, things that you strongly believe personally. And some of those may not affect your outward beliefs. For example, I have a very strong belief that I love garlic. That it really doesn't matter if other people like garlic or what the actual percentages of garlic, as long as I have access to it. I know I like it. I also like Brussels sprouts. The rest of my family despises them. So again, these are things that are probably not affecting others. However, I also have political beliefs, policy beliefs, and those will affect how I vote and how I actually interact with the rest of the world. I have beliefs about how coworkers are going to behave, and that also affects the rest of the world. So whenever we're looking at a belief, something that we believe in, we want to ask a few questions about that belief. We want to be systematic about it. The first question is where is that belief is coming from? And there's basically four possibilities. The one is that the belief is based on our own personal experiences. And that's fine for a lot of things, but we do want to recognize that if it is based on our own personal experiences, have we truly put it to the test? Have there been comparison groups? Has their confounds been checked? So for example, for the longest part of my life, I owned sports cars and motorcycles. I did not ever own a truck. And I had come up with a belief that trucks were dangerous, that there was basically, I had a little pocket theory that there were two types of truck drivers and neither of them good. Well, I now own a ranch and I own multiple trucks, and I've completely changed how I've perceived truck drivers. That's not to say that I don't still notice some of those bad behaviors, but I also notice all the good behaviors that I was ignoring before. So again, my dislike of trucks initially was based on experience. However, I really hadn't systematically asked, is this actually true? And I haven't looked for potential confounds as well. In fact, most of the trucks I was experiencing were people that owned them in larger cities that probably weren't actually using them as trucks. They were just using them to make a statement. Compared to me now living in a more rural area where most trucks are actually working trucks. So this also has affected it. And again, that's that confounds. Is it possible that I was noticing that people were not behaving in the best way when driving trucks because I was being exposed to city drivers owning trucks? The next question is it based on authority? In other words, have we been told it by an authority figure, our parents, our preachers, our pastors, our scientists, our professors, and we've just taken it as accepted? Now, honestly, a lot of what you're learning in college is based on authority. So the next question we need to ask whenever someone says something based on authority is where is that authority coming from? It may be based on the authority's research. In other words, it's well grounded in scientific methodology. And hopefully all the classes you're taking, including this one, are actually basing that authority on research and providing you with access to that research. It could also be the authority's personal experiences. In other words, we go back to that. It's not your experiences, but it's their experiences. So for example, if while I was a professor, I was also telling students that trucks were bad, that would be an example of people going, oh, trucks must be bad. The professor told me that. However, it's not based on research. It's based on my own personal experiences. And it could also be coming simply from the person's intuition. And we'll talk about that as a primary cause as well. But this basically means that someone has made a decision. They're communicating that belief as an authority figure, but it's not based on their personal experience. It's not based on their own research. It's simply based on their gut feeling, if you will. And that leaves us to the next possibility of this I believe. This I believe going to based on intuition. So this is biased often by faulty thinking. It's biased by motivations. And we're going to talk about faulty thinking, cognitive bias, and we're also going to be talking about motivation later in this lecture. But again, that doesn't mean intuition is wrong. In fact, I'm a strong believer in letting yourself kind of make decisions based on your gut, especially if you're not sure which way to go. In other words, if you've ever heard the phrase, trust your gut, that is intuition. And a lot of times intuition is based on things that we're not completely aware of, but experiences, you get that feeling that this is just the right thing to do. And that's not necessarily a bad way to make decisions in the immediate, but if we're building our belief structures on this, we want to put that to the test as well. And the final way that we can know and believe things is through research. And again, that's where this class is focused, and that's the entire bottom of this chart. So if it's based on research, basically it can be scientific sources such as psychologists or psychiatrists that are basically doing research and presenting in journal articles, chapters in edited books, full-length books. And if it is a journal article, we want to make sure it's an empirical article. They put their assertions to a theoretical test. They collected data, and they basically have ruled out other possible causes, and they've also ruled out what happens if the intervention, if you will, or whatever they're studying is not present. And that's one of the things we're really going to focus on, that control group that's a part of journal articles. And also that journal should include review of previous articles. So all of this is examples of building up knowledge through actual scientific research. This could also be based on other sources, so by psychologists, journalists, lay people, or popular audiences. And again, it could be drawn from trade books, looking for references, magazines and newspaper articles. Again, look for the references, or wikis, think critically. So that, again, there's been actual studies, for example, of Wikipedia, and it's found that it is as accurate, if not more accurate, than traditional encyclopedias. But that actually is not the greatest statement, because there's also errors in traditional encyclopedias. So whenever you read something, whether it is a media article, whether it's a trade book, whether it's a Wikipedia or some form of wiki article online, you do want to think critically still, and you may want to check out the original resources. So this is a good way to just kind of check, where is your beliefs coming from? Are they coming from your experiences? Are they coming from authority? Are they coming from your intuition and motivation? Or are they based on research? So research versus your experience. The biggest thing with your experience is it is potentially confounded, and there's no comparison group. So let's talk about these two, because they're also key concepts of what makes an empirical scientific journal article methodologically sound. The first one is that research actually generally will have comparison or comparison groups. So either one or multiple groups. In other words, if we're looking to see the effects of temperature on aggression, we also want to be testing what happens with aggression if there is no temperature increase. What's the comparison group? So for example, how do people behave aggressively, measuring aggression, when they're at 70 degrees versus when they're at 90 degrees? If we found a difference, more aggression at 90 degrees, that would start to build a better argument that it actually is temperature that's resulting in greater aggression. The other problem with experience is it is confounded. And confounded basically means, are there other alternate explanations? If we've completely controlled an experiment to where it's the same random people, so we start with 40 people, we randomly assign them into two conditions. In one condition, we do not increase the temperature at all. It is a comfortable temperature. And for an hour, we put them through various scenarios and we measure their aggression levels. At the same time, the other half randomly assigned, and we'll talk about random assignment as we move on in this class and its value and what it does and does not do. But for now, just assume that this is a way to kind of get rid of confounds. That comparison group that is actually in the same environment with the same experience at the same time, but it's now 90 degrees as they go through the same activities, and we we measure that aggression in the same way. It's hard to come up with another reason why one group would be more aggressive than the other. We've ruled out confounds. Our experiences do not rule out confounds. For example, if we notice that people in hot weather are more aggressive, and then people in cooler climates are less aggressive, have we actually determined if it's the actual temperature, It could be that the people that are more likely and willing to go out in the hot temperatures are more aggressive to begin with. That's a potential confound. We don't know. We haven't tested that. And that's why our experience often has problems. It has no comparison groups generally, and it generally has not anticipated methodologically and rigorously what the confounds might be. In other words, what the other explanations might be. So again, compared to what? Experience does not have a comparison group. And a lot of early science, especially medical science, is a good example of no comparison group. One of the initial findings, and was greatly accepted in medical science for almost 100 years, was the idea that one of the ways to cure someone's ailments was to bleed them, to basically reduce the amount of blood pressure and blood flow in the person by bleeding them. This could be leeches and etc. And generally, they found that when they bled people, most of them recovered, but some of them didn't. What was missing in this was actually what happened if you didn't bleed people. There was never a comparison group. And part of the first activity that you're going to be doing in this second chapter is actually looking at this and trying to kind of walk through the process of looking for those comparison groups. What happens when there is no treatment? So let me talk about that briefly. So again, when experience doesn't have a comparison group, researchers have to go beyond experience and actually put science to it and ask, what happens if we compare it to others? So for example, if we actually did a baseline comparison of the bleeding study, we compare people that are bled versus not bled, we might have found something very similar to this. The number of patients that recovered when bled was 20. The number of patients that died was 80, about 20% recovery. And without a comparison group, that might sound, well, maybe they were all dying before this, so maybe bleeding works. But if we actually then looked at another group where we were actually not bleeding, we might indeed find that there was a similar recovery rate. Now, this is not addressing confounds. For example, the people that were bleeding might be people that are actually doing better in general. They might be people that are wealthy enough to afford doctors. They might have better nutrition to begin with, which means that even then, we might actually find that the people that were bled do better than those that are not bled. But does that actually tell us what's going on? Have we gotten rid of confounds? Is there a difference between the people that are being bled versus those that are not being bled? So the people that are not being bled, a potential comparison group, might be poorer, less access to doctors, and less access to nutrition. So it has nothing to do with the intervention, bleeding or not bleeding. It might have to do with simply who these people are. So that's the main thing I'm trying to point out here is just having a comparison group isn't enough. We also want to rule out those confounds. But we can also see if we just decrease a value, we might actually find that not bleeding, for instance, the only thing we changed here was that very few patients died when they weren't bled, and a fair amount of patients did die. That would actually indicate that our hypothesis that bleeding is a cure to various ailments is actually refuted. 91% of people survive if they're not bled, 20% survive if they are bled. Likewise, we might actually find the other, that we actually find that bleeding does actually result in a greater chance of living. Only 20%, but those that weren't bled were dying at a much higher rate, and only 2% survived. So the idea behind this is not only do we want to think about what is the comparison group doing, what are we comparing to, are we ruling out confounds, we also want to set up our experiments to where we could either support our hypothesis, bleeding works, or refute our hypothesis, bleeding doesn't work. So some examples to this, again, you might ask, these are from relatively recent newspaper articles. So 76% of people who volunteer feel younger than their age. So does volunteering keep you younger? So what is that compared to? In other words, are there something unique about people that volunteer that also mean that they also are reporting younger in age or feeling younger, regardless of whether they're volunteering? Does reading the safety guide in an airplane keep you safe? Well, 70% of people who survive airplane crashes read the in-pocket safety manual before the flight. Is that actually resulting in them surviving, the fact they read? Or do people that take the time to read the packet are also a little more conscious of where they're sitting in the plane, have actually done research on plane crashes? There are areas of the plane that are safer in a crash than other areas. They may also be choosing those areas to be seated in. So what we want to do is actually, whenever we're confronting something, we want to think about, okay, what's actually being told? So we know that 76% of those that volunteer report feeling younger, 24% don't feel younger. So fill in that gap, because studies, especially media and newspaper stories, aren't going to give you that other half. So think about what that other half means. And then ask, what's the comparison group? Did they provide one? And what does it look like if you're not volunteering? So experience is confounded. When we evaluate our own experiences, we are not able to control for multiple co-occurring effects on our mood and our behavior. Not only our own, but also those of the people that we're observing. So we're not systematically asking what are other explanations. Any confound is an other explanation that could have caused the change or the effect that we witness. Expectations we weren't expecting tend to also be confounds. So if we find something we weren't expecting, that may also be caused by a confound. Now, it may also refute our theory, but it could also be the other. When we see a confound, it's not necessarily going to be good or bad. It simply makes us ask more questions. So again, getting into this idea of research is better than experience, research includes a comparison group, control for confounds, and strive to evaluate information without bias. So probabilistic, strong probabilities, for example. So in this case, this is a fairly classic study that actually put to test the idea that catharsis is helpful. That if you are feeling frustrated and angry and increase in aggression, one of the ways to reduce that effect is to let it out, to beat up a punching bag, for instance. And what they actually found when they put it into a controlled experiment, where they actually took people and randomly assigned them into three conditions, where they're either sat quietly and motivated, and basically it's not motivated, meditated while they were being put in a situation that was aggressive, allowed to punch a punching bag, so an exercise without a direct target, or they were allowed to punch a punching bag that included the person that had been frustrating them's face. In other words, a direct outlet without actually attacking the person. They then actually measured the subsequent aggression towards their partner as a z-score. And what they actually found was there was less aggression towards their partner after this experiment when they sat quietly and meditated. There was a slight but not significant increase when they just exercised. And when they actually exercised in a way that was cathartic, in other words, they punched a punching bag with the actual face of the person that had been frustrating them on it, they actually were statistically more likely to be aggressive. And this has been found over and over again. The catharsis hypothesis, the idea that you get out aggression by being aggressive, is actually not supported. Now, that doesn't mean that there might be some individuals who respond differently. There might be some individuals who have learned to allow catharsis to let them drain out that energy. But across the board, when we actually put this experiment to the test across a lot of people, we consistently find that catharsis actually results in greater aggression. And again, when we're looking at these differences, again, I'm kind of using a lot of terms we haven't quite got to yet, but I've used the term statistically significant. What that basically means is the difference is big enough that we can be fairly confident that it's meaningful. So when we look at this graph, I mentioned before that punching the bag or exercise did not result in a significant increase. There was an increase, and in fact, a media article might even say that exercising increases your aggression. Well, that was found, but it wasn't found to be strong enough for us to be confident that it wasn't just a minor variation in our measurement. Now, the difference that we found as far as aggression between meditation versus actually releasing our aggression on a target was significantly different. So when we're talking about probabilistic, so how likely something is occurring, that's what we're talking about with statistical significance. Basically, statistical significance can be inserted in your mind as it's strongly probable that. No experiment claims with 100% certainty that they've found something. They always claim it with a little caveat, the evidence strongly supports something. So your chapter 2 assignment, basically, you're going to see that in the chapter 2 assignment that's required, there are some various statements that have been fairly supported by media. And I want you to ask with each one of these to ask, what did they compare it to? Or what would you want to compare it to? I want you to draw that matrix of what is the percentage that was found, what is the percentage that wasn't found, and what would be a good comparison group. And with each one, I want you to think through what would be the possible confounds. So for example, drinking smart water as opposed to regular water helps me feel more hydrated. Going to the gym improves my memory. Drinking a tablespoon of apple cider vinegar a day reduces my blood pressure. White noise machines help me sleep better. Those are all statements that we generally, most people take as, if not fact, at least something somewhat supported. But I want you to ask, how about the people that weren't actually doing this? In other words, that drank smart water and did not report feeling more hydrated, went to the gym and did not report increase in memory. But also, what would be the comparison group? How would you compare that to another group of people? And if you did, what would be potential confounds with that other group? So again, another example is people that text feel closer or feel distant to those that are texting versus not texting. This would be an example of creating one of those matrices. So when we also look at research, we also have to recognize some of the other ways that we can know about the world, including intuition. Intuition is based on faulty thinking, cognitive bias, and intuition is also based on motivational biases. Now, this doesn't mean intuition is always going to be wrong, but it does mean that intuition is susceptible to potential cognitive biases. In other words, things that we do as how we process information. So cognitive psychology has looked deeply at how we actually process information. And what it's found is that we're fairly accurate at looking for patterns, quickly making conclusions about those patterns, and then acting according to those patterns. And this actually is a survival technique. If you had to scientifically test whether fire burned you by continuously testing that fire, you'd probably damage yourself a lot. So intuition basically tells us the very first time we encounter something that is red hot or on fire, we notice that is painful heat, and we avoid it from that point on. That doesn't mean we put it to the scientific test, and it also doesn't mean intuition is wrong. But it does mean that we have jumped to a quick conclusion. Though fire is an easy example, we also tend to jump to quick conclusions about people, behaviors, and beliefs, politics, and policy. We may also, once we've made an opinion, we're biased by motivation. In other words, motivational biases tend to look for further evidence that confirms our beliefs and kind of discounts evidence that might discount those beliefs. And we'll talk about those in a little more detail in the next few slides. So intuition is based on faulty thinking, what we all often call cognitive bias. We look for good stories. We accept conclusions just because it makes sense. So if we read a conclusion that validates what we already believed, we're much less likely to look into it in detail. We're much less likely to look at the references. We're much less likely to call it into critical thinking. What comes to mind easily, often referred to the availability heuristic, is things that come to mind and guide our thinking. For example, the media, and this is nothing against our news and our media, but they also are reporting things that tend to get attention. They're reporting what we want to read, which means, for example, serial killers are always hot button topics. When a serial killer erupts and we start finding them, news focuses on it, lots of stories, which means the availability heuristic makes us think that serial killers are actually a pretty big problem. They're actually statistically very unlikely. The chances of you ever running into a serial killer is very small. You're much more likely to die due to a car accident. You're much more likely actually to die due to swimming than being killed by a serial killer. But what comes to mind? Do we think about car crashes much? No, they're not really newsworthy. They happen every day. Same with swimming accidents. But we do think about serial killers, and that's the availability heuristic. It basically means that we tend to focus on what is noteworthy. We focus on plane crashes. Many of us have a little bit of apprehension whenever we get on a plane, even though statistically speaking, we're much less likely to die on that plane than we are to die in the car going to the airport. And that again is availability heuristic. When a plane does crash, it becomes major news. Everyone is made aware of it. When a car crashes, it barely makes the local news. So failing to think of things we cannot see, we focus on the positive incidences more than the negative ones. And here's a good example of this. So again, we have outcome present, feeling better, outcome absent, felt worse. And we have basically our statistics. So we express frustration and the treatment is present. 5 times we actually see people that feel better after expressing that frustration. So again, this is the catharsis experiment. But what we're ignoring there is we focus on what supports our belief, our availability heuristic. Oh, look, this person felt frustrated and they felt better after they let out that frustration. However, what we're failing to look at is when they expressed frustration and they actually were worse afterwards. In other words, more aggressive. We actually see 10 people in that situation, which means you're 2/3 more likely to actually feel worse after expressing frustration than not. And also, when we look at doing nothing, treatment being absent, we actually see more people felt better when they didn't do anything versus when they actually did. So again, what we focus on is what actually supports our beliefs. Expressing frustration makes us feel better. We know that, we note that, we pay attention to it. It's where the catharsis hypothesis started. But when we put it to the test, when we make this matrix of it, we start to realize, wait, that's actually a small number of people that are getting that benefit. So intuition is based by motivation. We have a focus on evidence that we like. This is confirmation bias. We seek and accept only evidence that supports what we already think. So confirmation bias basically means if I have made a hypothesis that, for example, truck drivers are bad, I'm going to just stick with that one. And a truck goes past me going the speed limit, doesn't do anything weird, and turns off, and I never think about it. Guess what? I don't even attend to that. But if a truck cuts me off and I already have a hypothesis that truck drivers are bad, guess what I attend to? I attend to that example. If any of you have ever gone gambling or know someone that gambles, they're always telling you about that time they had the big win. They're not telling you about all the times they've lost. And I know very few people that actually overall have actually come out way ahead gambling. Most of them are breaking even at best or honestly losing. My own experience, I go to Vegas once a year for various events. And when I'm there, I always take $20. There's been 2 times in the last 30 years that I've won with that $20. I've picked out a machine or I've gone to a blackjack table and I've won some money. And generally I'll stop immediately after. If I go over $20 in any substantial amount, and a substantial amount is usually about $100, I'll stop gambling and I'll say, I won $100 at Vegas. What that misses though is those other 28 times. So there's 2 times that I've won relatively big. I turned $20 into over $100, stopped gambling, and was happy with myself. And by the way, those are what I tell people about. It misses the 28 times I went to Vegas and I started with $20 and I left with 0. I'm not going to do the math for you, but I've definitely lost more than I've ever won. But I don't talk about the losses, I talk about the wins. So asking biased questions to get expected answers, confirmatory hypothesis testing. So a lot of times when we read a study even, we'll actually see this study is kind of stacked the deck to find confirmation, not necessarily to refute the hypothesis. A good hypothesis and a good methodological study should actually have almost equal chances. If it's really there, it should find it. If it really isn't, it should also refute it. So we ask questions that are more likely to give the desired answers. And by the way, this is human nature. I am not saying that scientists are not going to run afoul of these. They are. Everyone runs afoul of these. The goal is to strive as hard as you can as a scientist not to run afoul of these. And as a consumer of research, the goal is to read that research asking what were the biases of the person that did this study? What were they ignoring because of confirmation hypothesis testing? So bias without being biased, seeing bias in others and not ourselves is another thing, is that we are very quick to notice bias in others. It's harder for us to notice bias in ourselves. And that's another factor of human nature. We tend to look at the world through rose-colored glasses. And actually science has supported that. We've actually found that people tend to look at their most people tend to look at their situation more positively than they should. That is also a bias of our own evaluations. We tend to think we're less biased than others and notice bias in others quicker. So again, just coming back to that initial chart we started with, we can start to see that whenever we have a belief, we should first ask, does it matter what that belief is? If it's truly a personal belief that only affects you, then I think you can honestly, it doesn't matter where it comes from. But if it's a belief that you're acting on, if it's a belief that you're making choices on, you probably want to go through a more systematic process of asking, where did this belief come from? Is it based on authority? Is it based on your own experience? Is it based on intuition? And if the answer is yes to any of those 3, you may want to do a deeper dive. You want to critically think about it and see, does it survive the research? Do you actually find support? And check your own biases. Make sure you're not looking for just research that supports your opinion. There is studies that will support almost any opinion, and that's a part of science as well, and we'll talk a little bit about that. That's one of the reasons that science will never say 100% something is supported. It'll say that it's statistically significant, or there's a strong effect, or it's highly likely. And the reason for that is that if you run hundreds of studies, some of them are going to actually find something that isn't there. It's a natural tendency, and we'll talk about that in more detail, what that probabilistic chance actually is. It's one of the reasons we also do multiple studies. But that also means that if you, for example, strongly believe something, you can probably find 1 or 2 studies that support your belief. You want to ask the further question, do the majority of research support this belief? And if not, start asking why. It may be that there is some support for your belief, but it's a very specific type of belief. In other words, it only affects these people in these situations, not more broadly. But again, we want to just be critical, and that's what this class is about. It's critical thinking. So when you're actually looking for researches, as you're a consumer of research, not actually necessarily a producer, you want to think about where you're going to find information that's written for a scientific audience. In other words, research that's actually been published for other critical thinkers. That's their job is to think about these confounds and comparison groups. One of the areas is empirical journal articles, but even an empirical journal article that's published, you still want to ask for further questions. Who's the editor? What are their biases? Who are the funding sources? And I would still read through that article and go, do I agree with their confounds and their control groups? We might also look at, especially if we're trying to just do a kind of surface level, we may end up with a review journal article, an article that reviews all of the previous empirical articles and tries to summarize across the board what's finding. So for example, with the example of catharsis, the initial studies were empirical journal articles, single articles that looked at the question, does catharsis actually reduce aggression? However, there's been now several review articles that have looked at hundreds of empirical articles that have supported the idea that catharsis does not work for the majority of people. We might also look at edited books, so academic articles that are in books themselves, and these often resemble review articles. Each chapter tends to strongly base itself on previous research. But you still want to ask the question, are there particular studies they're ignoring on purpose? We can also sometimes find full-length books. So you've probably all at some point encountered the Milgram studies. So the Milgram studies at the very basic level was basically where someone was brought into a lab setting and was put in a situation where they were asked to harm someone else whenever they made mistakes learning. And as each time they made a mistake, they had to up the voltage. And what they found was that the vast majority of people believed they were actually causing potentially fatal damage on someone by the end of the experiment and never stopped. And Milgram originally set up this experiment to prove, by the way, that US citizens were not like Germans. This was shortly after World War II. He was trying to show that there was something fundamentally wrong with Germans. And the first thing he wanted to do was show that there wasn't something fundamentally wrong with Americans. So that's why he set up the initial study. He was shocked to find that Americans were just as likely to inflict harm when an authority figure told them to. This does not excuse the war crimes of Nazi Germany, but it does give us some information that any country, given the right situation with the right authority figures, could probably find people that were willing to do bad things. The reason I bring up this study is that the Milgram study was not actually published as an academic empirical journal article. It was published as a book by Stanley Milgram, where he combined many, many different studies in other countries as well. And by the way, he did find that Germans were slightly more likely to inflict harm than Americans, but not a large difference. And finally, where most of us probably find this information isn't through reading dry academic articles, and I'll admit, most of them are a slog. It's reading short articles that look at that research. And if that's where we're getting our information, we also want to ask those questions. What's the bias of this particular journalist? What's the bias of the organization he's writing for? What did he include? What he didn't include? And potentially, if we actually are planning to form an opinion about this, in other words, it's going to determine what we believe, we probably want to go back to those original sources. And if the sources are not listed, that should be a big red flag of whether or not you should believe that journalism. So when we're reading scientific sources, we want to ask questions. What is their specific argument? What was the evidence? And I would go further and actually create a quick little grid. What was the comparison groups? What was present when so basically think of that matrix again, and what was the effect found? What is the opposite of that effect? And what was found in a confounding group? In other words, a control group. And when we read an article, what we're generally going to find is the following. An empirical article is going to start with an abstract. It's going to have a title. It's going to have authors, and it's probably going to have affiliations. So if you're reading an article that doesn't include who the authors are and what their affiliations, and it doesn't have an abstract, it's probably not an empirical research article. And even that doesn't tell you it's an empirical article. It may be a review article. We're then going to hit the introduction, which is basically going to walk through what's previously been found. Then, if it's an empirical research article, there should be a methods and results section. What did they do, and what did they find? They're then going to drag those findings back to that original reference, and they're going to talk about the references that they've used. This is what we should be looking for when we're looking for an empirical article. If any of these things are missing, we're not looking at an empirical article. It may still be a well-founded article with lots of references. It may be a review article. But again, when I say empirical article, it's going to have an abstract, it's going to have an introduction, it's going to have a method, it's going to have a result, it's going to have a discussion, and it's going to list all of its references. In addition, what's not on here is it's going to list all of the authors and their affiliations. In other words, what institutes are paying for this research. So finding research in other places, obviously there is more places than just empirical articles. Trade books by psychologists, make sure that those references, and if, a lot of times these might not even be psychologists. So Malcolm Gladwell has written quite a few books that are very well referenced, but he's not a psychologist himself. He likes to write about psychological theories. He takes it and he makes it more digestible. But he still has the references to what he's supporting with. And you can look at those as well to determine if you agree with his assessments. And again, we see a lot of science writing in journalism. Use your critical thinking skills when you're confronted with this. It's going to help you work through this process. And if it is something, be critical to yourself. If you're reading an article and it's starting to affect your opinion or it's supporting your opinion, be more critical. Ask where they got their references from. Take a look at those original references. Ask what their biases are, and indeed, ask what your own biases are.